Hi, everybody. Yesterday we were taking the area and perimeter of shapes by using the distance formula in order to find the length of the shapes. Once we found the length and width or radius, whatever necessary measurements we needed to find, we plugged those into the formula and we found our perimeter and area respectively. Now we're going to be talking about still area and perimeter, but we're just going to be talking about how it's used in the real world. Whenever we use these to model something in the real world or a real life object, it is called a geometric model. A good model shows all the important characteristics of the object it represents, although some of the detail may be lost. Often you use a geometric model as a tool for studying an object. So we use geometric models for drafting for like houses. We can make 2D models of, for instance, molecules in science. There's a lot of things that we can make 2D figures for, two-dimensional figures for. So for instance, if we take a look at this starfish, the starfish can be modeled with a pentagon and 5 triangles. Pentagon is a 5-sided shape in the middle in red, and the 5 triangles represent its limbs. A honeycomb can be modeled using a bunch of connected hexagons. So again, we can use some shapes that we're familiar with to sort of build other things in the world, to study them more than we normally could if we're really looking for in-depth knowledge of them. So in order to better study these shapes, this is where area and perimeter come in. Perimeter is normally used to tell if you need something on the outside, like a fence, or you're laying something with garland to make it decorated, or you are wanting to paint something, you use the area. Sorry, I guess that was confusing. I was talking about perimeter. Area is used for if you want to paint something, you need to know how much paint you need on the inside. If you're filling something with dirt or sand, technically we need volume, but we can use area to help us find that. A lot of different measures help us find a lot of different things in the real world. So, taking a look at this shape, our job is to use an appropriate two-dimensional model and the dimensions provided in the image below to calculate the perimeter and area of the plate. Well, looking at this plate, I would say that it looks most like a square. I can see that the length and width are the exact same value, so that even more tells me that it's a square. If I see that it's a square, I can use the area equation for a square, which is whatever your side is squared, and I can use the perimeter equation for a square, which is 4 times the side, or adding up all 4 sides, which should be the same measure. So my area, since my side is 12.5, would be 12.5 squared, which means 12.5 times 12.5. And in my calculator, that would be, let's see, a second. While I'm getting the calculator loaded, I can do also for my perimeter 4 times 12.5. 4 times 12.5 in your calculator should give you 50. So I know my perimeter is 50. Looking at the unit, it's inches, 50 inches. 12.5 times 12.5 looks like it is 156.25. And anytime we have an area, it is our unit. And just like we squared it, it is our unit squared because we are measuring how many square units fit inside of an object for area. So we can use two-dimensional rules such as area and perimeter, to figure out more things about the objects that we are dealing with. Okay. And we'll go through one more example for those who need it. If you feel like you already understand it at this point, feel free to turn off the video and you can go towards working on your DOL. However, for those who are maybe confused or would like a little bit of extra help on a different type of word problem, make sure that you're paying attention and we will go over this problem. Isaiah owns a small cafe. On the right, we can see this layout. We see a coordinate grid in the background. So probably going to have to use the distance formula to figure out some different measurements, but we can see the layout of the cafe. We have the counter, which is a C, floor space, which is A, tables, which are labeled T, and the drink station, which is labeled D. So part A tells us that a new fire code states that there must be 15 square feet of free space for every customer in the cafe. Using the cafe's floor plan, determine how many people can be in the cafe at one time. So to answer a question like this, the first thing that we want to do is find out how much free space is available. Or I guess our ultimate goal is to find out how much free space is available. So looking at the diagram, realistically, you're not going to have people standing on the tables, standing on the counter, or standing on the drink station. So we have to take those away from the amount of available area that there is. So here they kind of have it laid out. To find A, the amount of people, or the total free space, we should figure out what the total area of the cafe is. And in my head, I'm looking at the floor layout, and it looks like it's either a square or a rectangle. To be safe, I'm going to say a rectangle. It's probably a square. So we would find the area of the square, and we need to subtract the things where people cannot stand. So we should subtract, well, this has a 2 in front of it, meaning there's 2 somethings in the room, and I see that there's 2 tables in the floor. So I should take away 2 tables, all right, because people can't stand on the tables. I should also take away the counter and the drink station because people can't stand on the counter or drink station. So I should also subtract the amount of counter space and subtract the amount of room that the drink station takes up. Again, total area of the cafe would be by finding the area of the square. T is the area of the table. C is the area of the cafe counter. D is the area of the drink station. The tables look like they are rectangles as well as the counter. So we would use area of those to find what we should subtract. And the drink station looks like it's a triangle. So we'll use the triangle equations for that. Okay. Step 2, find the number of people that can be in the cafe. Well, we have, if you solve this, if we were to go through and do the areas, which would make this video too long, it looks like we would be able to fit, we have 157 square feet of available room. We times that by the amount of room that a person takes. This fraction is saying one person for every 15 square feet. One person per 15 square feet. So we take the 157, we multiply it by 1, which is 157 still, and then we divide it by 15, and we see that, well, we get an answer of 10.5. However, there's no such thing as half a person. Every person is fully a person as far as rights, so don't ever consider somebody a half person. we cannot safely fit more than 10.5 people in there. So we should go back down to the nearest number that we were allowed to fit. We are allowed to fit 10 people in there. I know it rounds up to 11, but 11 would be above what we're allowed to fit in there. 10.5 is the exact number that we can fit in. So we should go down to the next number that makes sense, which is 10 people. Now, if Isaiah wants to hang garland around the tables and drink station, how much garland does Isaiah need? Again, if he's hanging it around things, that is a hint that we need to find the perimeter. The area measures how much space something takes up, whereas the perimeter is a measurement of the outside of a shape. He wants to hang this garland around the outside of the tables and drink station. So if we look at this equation right here, the length of garland needed would be 2 times the perimeter of the table. The reason for this is because we have 2 tables. Plus, we need enough garland to go around the drink station, so we need to calculate the perimeter of the drink station. So we have this, 2 times 2 length plus 2 width, which is our equation for the perimeter of the rectangle. In here, they've done the distance formula. 6 plus 5, there should be a plus in here, plus this. Again, that is the distance formula to find the diagonal side. Once we find the diagonal side, then we can add the 3 numbers together to find our total perimeter. So here they did the distance formula to find the length and width of the table. Again, this is a skill we learned yesterday, so make sure that you can still do that. All together, we add it all up and get about 45.6 feet of garland. If I was Isaiah, I would go safe and just buy 46 feet. Also, it'd be weird to tell somebody, whoever is cutting your garland, hey, can you cut this to 45.6 feet? All right, so this is an idea and kind of an example of how we can use area and perimeter to model and solve real life problems. Make sure that you try the 2.3 plus DOL, and I will see you all tomorrow, whether it be online or in person.